So thanks a lot, everybody, for coming to this session. So I think this page has stayed there for so long, so you know what I'm talking about. And just to give you an idea, like what is DALL? For those people who don't know about DALL or this generative art, is you give a sentence, right? So your input is a sentence, right? And there is an almighty AI program, and then generate this image from this sentence, right? So notice that there is no initial image, right? So your only input of your program is a sentence, right? So this is, for example, ocean beach front view in Van Gogh style, and then this you use it as input, and then the output is this artwork, right? And then here is another example, a Statue of Liberty wearing a VR headset. And another example, which was very beautiful, is also generated by our community, painting of a couple kissing nebula. Right? So you can find more artwork by visiting GitHub, Gina-AI/DALL-Flow, and check it out. So today, my talk, at the end of this talk, you will learn how to generate this, how to build such program, in Python, right? Okay, so we also have a special announcement. So we have a mini raffle. If you look at the hotel, if you look at it in the buffet area, right? So in the open area, so we have a lot of artwork hidden inside this hotel, right? So in total there are 6 of them. So you can take one of them, you can take a picture of one of them, and then tweet about it, and remember to mention us at GinaAI_, and then at this afternoon at 2 p.m. we will have a raffle, and then if you win the raffle, you can take one of the artwork home. Right? So make sure you come to our booth. So our company, just to give a short intro about our company and my background, our company is very young. It's founded in February 2020, but it's one of the fast-growing AI company in the world. So we have 15 members in the world, a headquarters based in Berlin. We have other offices in San Francisco, in Beijing, in Shenzhen. We raised $38 million in the last 2 years, one of the top tier AI companies in the world. So CB Insight AI 100 in 2021 and also 2022. So Forbes, German-speaking country AI 30, those are the honors that we get, right? So what do we do, right? So we are the creator of neural search. We contribute a lot of things to open source, especially we use Python very heavily, right? So very deeply and heavily. Right, so those are the open source projects. If you go to our GitHub, you will find that all this open source portfolio that we have been built over the last 2 years. So those provides you the end-to-end full stack experience for building neural search from scratch, right? And so today's topic is a little bit heavy, right? So it's not I labeled as an intermediate level. In fact, there are a lot of knowledge to be passed during this 30 minutes. But let me build the story, so hopefully at the end of this talk, you can learn something, right? So the first part of this talk is focused on neural search, and then we come to DALL. All right. So what is neural search, right? So to start simple, let's consider this interview question, right? So you want to build a search engine, not a search engine, but a simple text tools that can search for a sentence from a book in a very fuzzy way, right? So fuzzy means that it doesn't have to be like 100% exact match. It could be acronym, synonym, this kind of things, semantically similar, right? So think about this, right? Think about this for a while, right? So how do you want to build? So basically, it's a grep, right? So it's like a grep in Linux, right? But it's like a fuzzy version of that, right? So for example, you want to search for "she smelled too much" in this Pride and Prejudice in this book, and then the output is the following, right? How do you want to build such thing, right? In Python, right? So it turns out with one of our open source project, Docker Ray, it is super simple, just 14 lines of code, including first download the book and then split the sentence. Here I just use a very simple splitter, by the end of the line, and then I use a very simple. It's not even like a natural language processing, it's just a feature hashing, a very simple heuristic to build the feature vector for each sentence. And then finally I build my query, she smelled too much, and I build the feature hashing again, and then I do the match, and here comes the result, right? So it's very simple, just 14 lines of the code, you can build your own fuzzy grep. And then here's another question, but it's not from natural language perspective, but from the computer vision perspective, right? So let's say you have a database. You run an e-commerce company. You have a stock articles, a lot of fashion clothes, shoes, trousers, and so on, right? And then you want to build a very good old cliche. You want to let people to take a photo of someone, and then you want to find the clothes or the dresses in your database, right? Visually similar dresses in your database. How do you build that in Python, right? So to just to think about it, but again, I will review the answers here. So you can use Docker Array again, which is a very nice data structure for unstructured data. And then write all the things in just 20 lines of code, 25 lines of code, right? And if we upgrade the level, the difficulty a little bit more, right? So image seems like okayish to handle, but what about the 3D mesh, right? So what about you're building a game engine and then you want to search for a lot of meshes data inside this game asset store, right? So this is a real example that we get from one of our clients. So they are building a kind of like a developer platform on top of Unity. So they have a lot of 3D meshes assets in their asset store. And then they want to build something like a look-like a plugin, right? So it's like you drag a dinosaur into your game scene and right-click on the dinosaur and then found look-like dinosaurs or monsters, right? And then they can automatically fill in the scenes, or without more like a too much human effort, right? So now you can think about that. Now it looks like not very trivial, right? So like an image is okay. It has been there for like many years. Text is of course like all this elastic Lucene. It seems to work like over last 10 or 20 years. And but what about 3D mesh, right? And here's another question. Here is another example, but it is also on text, but it's a next level text understanding, right? So I guess because we are PyCon conference, I guess a lot of people know about Fast API, right? So from Sebastian. But how many of you notice that there is a chatbot on the right corner of the Fast API documentation website? And then you can ask this chatbot any questions about the documentation, like how is the Fast API, how the speed of Fast API, and what the relationship between Fast API and Pedantic, and why does Fast API use asynchronous all the time? And then this chatbot will give you the answer, right? So this is by the way, so this chatbot is powered by Gina AI, by us, right? So this gives you another level of text search, but it's it's kind of like a closed domain question answering. So it's not really like you just found some sentence and that's it. The input is a question and the answer must be a natural language answer, right? So this is a next level of text search, right? So as a summarizer, the neural search is basically about using deep learning to do information retrieval across different modality, right? So let's say you have 3D mesh, you have speech data, you have 3D mesh, you have movie data, you have audio data, image data, of course, and then you want to build a relationship, using one to find the another, right? Or using multiple things to find another multiple things, right? So this corresponds to the cross and multimodality search, right? So that is basically a very short summary of neural search. And is this solved, right? Is this neural search solved? So there are a couple of fundamental questions, like from the machine learning perspective, like how do you quantize the semantic? How do you store the semantic? How do you generalize your granularity to larger scale and so on? But the most important thing for us, for engineers, right, is how do you bring such very machine learning prototype things into production, right? And this is what we provide to you, right? What our company provides. Like all the open source technology stack is for this purpose. Okay, so let's hold it for a minute. I know it's a lot of content, but now comes even more content, right? So it's like a DALL flow, right? The DALL and Diffusion, which is a new technology released by OpenAI since 2021, right? So the first version of DALL is released by OpenAI in 2021, and then there comes the next version of DALL 2, which happens just like a few months ago this year. And some of you may notice that Google also released ImageGen, which is another kind of text-to-image generator, right? So to understand DALL flow is not, easy. Most of the reason is that OpenAI never really open source DALL-E, right? So, but given the publication and the blog post that OpenAI released, you can somehow reverse engineer all the techniques behind DALL-E, right? And there are also a couple of YouTube videos to explain this. I recommend you to watch them. There are also some internet celeb which is not really in this domain. It also explains DALL-E very nicely, right? To understand DALL-E, you have to understand these 4 main technologies, right? So one is a Google BERT model released in 2018, and then VQVAE. This variational autoencoder, and then clip model from OpenAI, and finally diffusion net also from OpenAI, right? So these are the 4 pillars to understand DALL-E, right? So I will not explain this into very details here because this is not machine learning conference, but I'm going to just give you a very short summary of how does it work, right? In the first version of DALL-E, people use clip text embedding, clip encoder to convert the input sentence into a text embedding, and then they build a variational autoencoder to decode this sentence embedding into a complete image, right? So of course, all these things can only happen if your training data contains a lot of these image text pairs, right? So this is the first version of DALL-E, right? And this is also the DALL-E flow that we are going to talk about is based on. And then the second version of DALL-E add something called diffusion in the middle, right? So after you convert, you're using clip model to convert into text embedding, you add a diffusion layer, and then use this diffusion layer to convert this into image embedding. And then use the decoder again to convert the image embedding back to the full image. So this is DALL-E 2. So there is a very nice open source library from us, very popular, more than 10,000 stars. It's called Clip as Service. Excuse me. Basically, it's OpenAI clip model, but you build it. You can use it as you can host it as a service, and you can query it via gRPC, via HTTP, via WebSockets, and so on, right? So it's very convenient to use. So to understand a little bit about diffusion, diffusion is a different kind of technology. It basically, people use it for upscaling, for denoising the image, right? So the process looks like this. So during the training time, they build a kind of like a Markov chain, this kind of model, to randomly add some noise into the original image, right? So like from the right-hand side, you have the dogs, and then left-hand side, you have no dogs, like all the random image, random pixels there, right? So, but you add this noise step by step, right? And then they build a neural network at each step to try to recover the original image, right? So try to build, add a neural net, train all the things all together, so that at the end, the neural network is capable of denoising the kind of a fuzzy image, but also upscaling, right? The image into original size, right? So that is why the diffusion network can often produce very good, very high quality image, and it can improvise a lot. For example, this is generated by diffusion network. It is some sci-fi scene, but I forgot the prompt. But it's So this, I remember the prompt is like a satellite using yellow laser beam to hit the Earth in order to destroy the Earth. Right? So this kind of like the the prompt. This I also forgot the thing. I just like this artwork, right? But if you compare DALL-E and diffusion, so in terms of the speed, DALL-E is of course very fast, and diffusion is very slow because it's kind of like an LSTM or recurrent network, Markov chain. You cannot really skip the step. You can only do step by step, right? So in terms of the quality, DALL-E can only generate okayish artwork, but diffusion really can make your artwork to the next level, right? In terms of the quality, image quality, and very tiny details, right? So then what is generative art? Like, how is generative art related to neurosurgery, and why we, as a Gene AI, will care about this, right? Why should you care about this, right? So generative art, is also about building the relationship, right, between different modality. But compared to neurosearch, where the generative art, sometimes you don't have the other modality. You only have certain modalities, and you want to use the relationship to generate the data to other modality, right? So where the neurosearch is about, you have all you have the data in different modality, and you want to search for it. So you can see one side is more on the discriminative machine learning or discriminative AI. The other side is more generative AI. Right? They together build up this cross and multi-model applications, which is really the expertise that we have at Gina AI. Right? Okay, so now come to the third point, which is more engineering. So how does Gina work to help you build multi-model and cross-model applications? Right. As I said, we have a lot of things in our portfolio, in our open source portfolio. But let's first focus on, the very fundamental concept, which is document, executor, and flow. Right. And so those three concepts are so fundamental that once you master these three concepts, you can basically build anything, like a click-based service, DALL flow, all these things that you can build it very easily, right? So document is kind of like let's say ND array in NumPy, or tensor in TensorFlow, or in PyTorch, which is like a basic data structure in Gina ecosystem, right? So it is used to represent unstructured data, used to represent multi-model data, cross-model data, and it can be transmitted, serialized as protobuf, transmit to another microservice, sending, receiving, all these kind of things, right? And executor is kind of like a Python class or Python function, a group of Python functions but it works like a microservice, right? So instead of using standard input-output, it actually receives a network request, then totally work like a microservice. Flow is orchestration, right? Flow is about connecting, streamline all the executors, and to build up a job, right? To accomplish a job. So let's look at the hello world in just 15 lines of code, right? So in the first line, we just, of course, pip install Gina, and then from Gina import these three concepts, and also the request decorator. And then the second step, we define an executor, right? So in this executor, you can see we subclass from the executor class, and then we have this async def, right? So everybody likes it, but nobody use it, right? We have this async def, and then decorated by request. And then it receives a document array. So document array is a plural form of the document that I was talking about. And then for each document inside the document array, we add a hello world, right? So we append the hello world string to the original document, right? And then we build a flow. This flow is nothing but contains two things in a chain, two my executor in a chain. So you can imagine the output would be hello world and then a hello world again, right? So to use a flow, you can just open it as a file, right? So like a Waze, using this Waze context manager, you open it and you post something like when you do the post request, but here everything is working under gRPC by default because of the efficiency, because of security and so on. But then of course you can very easily change back to HTTP, HTTPS, and also like WebSocket, WebSocket-S, right? And finally you print the text. Right. So if you run these things, you will get this result. Right. So you see that it's like starting something, and then there are some endpoint exposing, and finally you have the results like hello world, right? Because we build two documents, so that's why you see this twice. Right. And because the flow contains two same executor, that's why you see like two hello worlds like in the same string. Right. Okay. So now the question from many of you after seeing this demo is, this is so cool, but why? I can write the same thing using just 12 lines of code, but doing exactly the same things as you do here with 15 lines of code. So it seems that you add 3 lines of code for what? Like, what is the purpose of using these 3 lines of code? Right, adding this 3 lines of code. So by the way, this side on this darker version, this is basically standard Python, right? So standard Python, you have document class, and you have function, and then you do functions, for loop, right? 12 lines of code. Well, on the other side, you have 15 lines of code. It's a kind of Gina EDM, Gina coding style, this kind of thing, right? Okay, so 3 lines of code for this, right? So for replica sharding scalability, for duplex streaming, asynchronous non-blocking data processing, for enabling gRPC protobuf, gRPC WebSockets HTTP GraphQL gateway, for using it as a microservice, for orchestration, for Kubernetes support, for observability via Grafana, and and also for respect face from your ego engineer friends. Right? This is because, to be honest, like many of you who work in the cross-model and multi-model things are usually coming from the machine learning or data scientist background, right? So when you talk to your engineer friends, they were like, nah, you are not doing anything like how software engineers are supposed to do, and but I will explain that later, right? So all these layers, all these concept, executor flow, all these things, it's not like something that we imagine. It's not something like we imagined and we build it for nothing, right? So if you look at any neural search applications in production, this will always contain these 7 layers. So let's play this animation again. So it's very nice. So at the bottom, you have the network computation layer. On top of that, you have data types, and then you have logic, runtime, microservice, orchestration, and to the applications. Applications is your final SaaS or whatever these things, right? So, but are all these 7 layers, necessary to the users or to the developers especially? Actually, no. So we actually abstract all these layers. We hide some of the layers from the developers. So in the end, you only have to care about 3 things: data types, logics, and finally the orchestration, right? So you can see these 3 things correspond to the 3 little guys that I was talking about. So the data types corresponds to the document, the logic corresponds to the executor, and finally the orchestration corresponds to the flow, right? Okay, so there is a bonus topic is what cloud native, because this is not the KubeCon, but I will just briefly go through the cloud native because there are not so many slides about it. So here is a question, choose a cloud native framework from one of the following framework: A, TensorFlow; B, PyTorch; C, NumPy; D, scikit-learn. Right? Any idea? Okay, so this is a trick question because none of them is cloud native framework. So in order to build a cloud native applications, you at least have to satisfy these 4 elements, right? So one is orchestration, microservice, containers, and observability. Some say the 4th pillar is DevOps and CI/CD, but I would say observability is more important. So why do we need neural search to be cloud native? Why do we need such technology marriage, right? So here is a very short summary about to justify this marriage, right? So neural search, when we look at neural search applications, usually it is not a single task, right? So it usually works as a pipeline, right? So for example, you build a search system, then you have pre-processing the data, encoding the data, storing the data, retrieving the data, ranking the data, aggregating the data, and then render the data back to the front end, right? So it's a pipeline, it's not a single task. There is no monolith program can magically solve it. So in this case, microservice is a very good idiom to explain, to build up all these single tasks. And then finally, you orchestrate everything together into a pipeline, right? And then the second thing is, I know a lot of people who work in machine learning, very enthusiasm, and then, after 2 days of installing all the CUDA driver, PyTorch, and TensorFlow, they give up, right? So they are not even write a single line of code, but just wasting a lot of time on the dependency issues, right? And then, so in the cloud native settings, Docker containerization is a perfect solution to help you freeze all the dependency to make your software somehow immutable, right? And finally, the neural search, when you build a neural search applications, it is often not the consumer-facing applications. It often work as an infrastructure. So to build a stable, robust infrastructure, you need a DevOps, CI/CD, and observability, right? Because other software are depending on you, right? Okay, as a summary of GNet technology stack, neural search, cloud native, all these things. So when you write an application, your originally starting point is often like this, right? So And then you move horizontally using all the machine learning tech stacks like SciPy, NumPy, Jupyter Notebook, Onyx, TensorFlow, PyTorch, and then you build up your POC, right? But usually your POC doesn't care about network, microservice, all these kind of things. It's work only locally. But you are very happy because it's running on Jupyter Notebook or whatever. And then the second part is, you bring this thing into production, right? And then you need a lot of cloud native things that you are not like, but engineers like a lot, like Docker, Kubernetes, gRPC, GraphQL, all these kind of things. So our mission, right, with Docker Array and Gina, this Docker Array, as I said, is a data structure for unstructured data. Gina is a cloud native framework to help you build cross-model and multi-model applications. And our mission here is to help you move, to accomplish this procedure much faster, right? Run into the result. And then, of course, as a side effect, our eager engineering friends will give you some respect, right? Okay, finally understand DALL flow, right? So now we have everything, right? We have understand what is neural search, what is generative art, how the DALL works in a nutshell, and how Gina can help you to build multimodal and cross-modal applications. Now is the time to explain DALL flow, right? So DALL flow is also an open source project. You can find it on GitHub. So it works like a client-server architecture. So it combines the DALL and diffusions that I was talking. It's not only DALL, it also has a diffusion pathway. And then it only contains like 288 lines of Python and 48 lines of YAML. It's a kind of a weekend work. But basically this shows you, with the help of Gina ecosystem, how easy it is to build such complicated things, right? So you can look at the flow, it looks like this. So this is 47 lines of YAML code. And then this basically corresponds to the or workflow that you see on the other side, right? So if you zoom in to this workflow, to this YAML file, it is not that scary as you would imagine, right? So on the top, you have the flow configuration. Basically, there you can set the port, the protocol to gRPC or HTTP. You can have some global environment variables. And then on the other side, on the bottom, you have all this flow specification composed by different executors, right? As I said, executor is kind of Python class, but work as a microservice, right? So you have DALL executor, diffusion executor, re-rank executor, upscaler rank executor, and store executor, right? So each executor, so let's play this animation again. So each executor corresponds to their own Python bundle, right? So there contains some entry point of the Python file. And then what's the point, right? So what's the point of having all this kind of specification is that each executor works as a microservice, where they can be wrapped inside the Docker container automatically, and then you can orchestrate everything using Kubernetes or Docker Swarm. Or if you don't like, all these cloud native things, simply run it, using Flow, using Gina Flow. So we have a mini orchestration built on top of Python, which is also very efficient. It also works. Right. Okay, so now, finally, I will just spend some time on the client workthrough. I think that's almost the end of my talk. So let's go to the, so you can, if you have, you have laptop, you can go to DALL Flow website and then click Open in Collab. And then this will brings you to this page, right, to this page. And then, so this is a Google Colab. You can run the DALL flow. This basically describes how do you run it on the client side. So what I was explaining is on the server side, right? So the first step is to run the Gina. So let's zoom in a little bit. So the first step is to install the Gina. And then the second step, after you install this, you can restart this, and then you cite the server URL. So notice that this protocol is gRPC / because we use by default is gRPC protocol. And then, I'm always curious because Florence is pretty pretty warm compared to Berlin, right? So I always like, can we host a Python conference underwater, right? And then let's use it as a prompt, right? So, and then you build up the your document with this text prompt and then send it to the server. And then for each pathway, so remember I said we have two pathways. One works through the DALL, one works through the diffusion. Each one of them gives you 8 images. So in total, you have 16 images, right? So let's look at the images that we got, right? So, as you can see, the first image works very nicely. This is not magic because after this diffusion and DALL, we have 60 images and we re-rank it via clip as service. So the most reasonable images is on the top, right? And after that, so I select these images, use it as a base image, and then I do some diffusion. So diffusion is basically, as I said, is polishing the image quality even more, especially paying more attention on the details. So I choose the skip rate as a 0.8 and generate 9 images out of the original base image. And finally, I choose one of my favorite one from this diffusion, all the diffusions one. And the final step is to upscale it to 1024 to 1024. And that's basically it. And here you go. You have the hosting Python conference underwater, right?
We don't have time for questions, so please, if you have any, ask in the corridors. Thank you very much.